Hello, young explorers. Today we're going on a fun adventure into the world of math. We'll discover two magical ideas, continuity and differentiability. Don't worry if those words sound big and tricky right now. By the end of our journey, you'll see how simple and cool they really are. So get ready for some colorful graphics, playful animations, and easy explanations that will make these math concepts as clear as day. Let's jump right in and start our math magic adventure together. Imagine you're drawing a line on a piece of paper without lifting your pencil. That's what mathematicians call a continuous line. In math, continuity means you can draw a graph without any jumps, holes, or breaks. It's like walking on a smooth path without tripping or falling into a hole. If you have to lift your pencil, the line isn't continuous. Easy, right? Let's see some examples to make it even clearer. Picture yourself walking along a garden path. If the path is smooth and you never have to jump over gaps or climb over rocks, that's like a continuous function in math. The path lets you walk smoothly from start to finish. In the same way, a continuous graph lets you move along it without any sudden stops or jumps. Let's look at a drawing of a smooth, curvy line to help you imagine this. Now imagine the garden path has a big hole in it. You'd have to jump over the hole to keep walking. In math, if a graph has a gap or a sudden jump, it's not continuous. You can't draw it without lifting your pencil. This is called a discontinuity. Let's see what a broken path looks like so you can spot the difference. Continuity isn't just for math. Think about pouring juice into a glass. If you pour smoothly, the juice flows in a continuous stream. But if you stop and start, the flow is broken. That's like a discontinuous function. So continuity is all about smoothness, whether you're drawing, walking, or pouring juice. Now let's talk about another magical math word, differentiability. It sounds big, but it's really about how smooth a curve is. If a curve is not only continuous but also has no sharp corners or sudden turns, we say it's differentiable. Imagine sliding your finger along a smooth slide. If you never feel a bump or a sharp edge, that's differentiability. Let's imagine a slide at the playground. If the slide has a sharp corner, you'd feel a sudden bump as you go down. In math, if a graph has a sharp corner, it's not differentiable at that point. The curve isn't smooth there. So differentiability means the graph is not just connected, but also super smooth everywhere. Think about drawing a hill with a crayon. If you can draw the hill in one smooth motion with no sudden changes in direction, the hill is differentiable. But if you have to make a sharp turn like drawing a mountain peak, that point isn't differentiable. Differentiability is all about smooth, gentle curves. Let's compare the two ideas. All differentiable functions are continuous, but not all continuous functions are differentiable. That means a curve can be smooth and connected, but if it has a sharp corner, it's not differentiable. So differentiability is like a special kind of smoothness, even smoother than continuity. Let's look at a wavy line that goes up and down but never breaks. This is a continuous function. You can trace it from start to finish without lifting your finger. It might twist and turn, but it never jumps or stops. That's the magic of continuity in action. Now let's look at a super smooth curve like a gentle hill. There are no sharp points or sudden changes. This curve is both continuous and differentiable. You could slide down it without any bumps at all. That's what mathematicians love to see in a differentiable function. What if our curve has a sharp point like the tip of a mountain? At that spot, the curve is still connected, but it's not smooth. That's a place where differentiability fails. You can see and feel the difference between a smooth curve and a pointy one. Imagine going down a water slide. If the slide is smooth, you glide down easily. But if there's a sudden bump or a sharp turn, you might get a jolt. That's the difference between differentiable and non-differentiable curves. Smooth slides are like differentiable functions. Let's try drawing a continuous line together. Take a crayon and draw a wavy line on your paper without lifting your hand. See how easy it is. That's what mathematicians mean by continuity. You can make any shape as long as you don't lift your crayon. Now try drawing a zigzag line with sharp corners. Each time you change direction suddenly, you make a point that isn't differentiable. The line is still continuous, but those sharp corners break the smoothness. That's the difference between just being continuous and being differentiable. Do you know that many things in nature are continuous and differentiable? The curve of a rainbow, the edge of a leaf, or the path of a river are all smooth and beautiful. Nature loves smoothness, just like mathematicians do. Continuity is important because it helps us predict what happens next. If a function is continuous, we know there won't be any surprises or sudden jumps. That's why engineers, scientists, and even artists love continuous functions. They make things smooth and reliable. Differentiability is important for understanding how things change. If a function is differentiable, we can measure how fast it's changing at any point. This helps us in science, engineering, and even in making video games. Smooth changes make everything work better. Tangent line is a straight line that just touches a curve at one point, matching its direction. If a curve is differentiable at a point, you can draw a tangent line there. If there's a sharp corner you carve, tangent lines are a fun way to see differentiability in action. Think about a car driving along a curvy road. At any smooth point, the direction the car is heading is like the tangent line to the road. If the road has a sharp turn, the car can't smoothly follow it. That's why differentiability is important for safe, smooth rides. To check if a function is continuous, ask yourself, can I draw its graph without lifting my pencil? If yes, it's continuous. If not, there's a break or jump somewhere. This simple test works for all kinds of graphs. To check for differentiability, look for sharp corners or sudden changes in direction. If the graph is smooth everywhere, it's differentiable. If you spot a pointy tip, that's where differentiability fails. It's like checking for bumps on a slide. Let's watch a frog jump along a path. If the frog hops smoothly, the path is continuous. But if the frog has to leap over a gap, that's a discontinuity. Animations like this help us see math in action and make learning fun. Now let's see a penguin sliding down a hill. If the hill is smooth, the penguin slides easily. But if there's a bump, the penguin gets a jolt. This shows the difference between differentiable and non-differentiable curves in a fun way. Remember, continuity means you can draw a graph without lifting your pencil. It's all about smooth, unbroken paths. Whether you're drawing, walking, or pouring juice, continuity is everywhere in life and math. Differentiability means the curve is not just connected, but also super smooth, no sharp corners or sudden turns. It's like sliding down a hill without any bumps. Differentiability helps us understand how things change smoothly. So what's the big difference? All differentiable functions are continuous, but not all continuous functions are differentiable. Think of it like this: all smooth slides are connected, but not all connected paths are smooth. That's the magic of these two ideas. Let's practice. Try drawing different lines, some smooth, some with sharp corners, and some with gaps. Can you tell which ones are continuous, which ones are differentiable? Practicing helps you see these ideas in action and makes you a math magician. You'll find continuity and differentiability everywhere, from roller coasters to rivers, from rainbows to racetracks. These ideas help us understand the world and make things work better. Math isn't just numbers, it's part of everything we do. You did it, now you know what continuity and differentiability mean. You can spot smooth curves, sharp corners, and jumps in graphs. Keep exploring, keep drawing, and keep having fun with math. Remember, math magic is always around you.